So maybe just to take a brief look at the sort of basics about difference in between open loop and closed loop. I mean, since open loop and closed loop evaluation are focused on different aspects of AI model testing. In an open loop evaluation, the AI model is tested against a recorded data set. In open loop evaluation, it's used basically early and frequently in the development to train and compare perception, prediction, planning models or modules on a large data set. It's fast, provides us ability to iterate really fast. Um, and we actually can extract objective model level metrics, which is really useful during the development phase. Some examples of frequent metrics are, for example, precision and recall for object detection. If you think about vehicles, pedestrians, traffic signs, etc. Maybe lane boundaries as well, if you have in mind the lane keep assist function or something like that. Um, Although such information is extremely useful during development, alone it can be actually misleading, since at first glance, small error can in subsequent time point propagate further, basically accumulate over time, and lead in real world testing towards, for example, lane departure, if you think about lane centering or lane keep assist function. Uh, so if you accumulate every frame error in lane position estimation, then basically in real world testing, the car will depart from the ego lane, and you will not see that behavior, or it's much harder to anticipate such behavior in open loop testing. On the other hand, the closed loop evaluation incorporates the AI model in the complete driving system. So unlike in the open loop testing, here feedback loop captures how errors accumulate or diminish or interact with other components as well. And it's much easier to see if, for example, constant bias in the estimate of lane position initiate lane departure when it should not. Since every action system end up in a new state, and then sensors need to read that new scene. Sensors have a new and potential different view to the scene, not the same or very similar as it is in the case in the open loop testing, because you don't see in the open loop testing the results of the action you took in the previous time point. Maybe another interesting example is autonomous emergency braking, where in closed loop testing, after vehicle initiate hard brake, you can imagine a camera pitch angle. If you think about cameras, then pitch angle can change significantly and abruptly because the vehicle is braking. And that can potentially affect detection and tracking performance of the most critical object you have in front of the car, because which initiated brake at the beginning. And because of that sudden change in the calibration parameters of the camera, what can happen in theory, right, is that you get biased detections in those critical moments, which can either abort the braking when it's actually needed, or prolong it when it's not needed at all in case of a false brake, for example. And all that is really hard to see in open loop testing, and closed loop testing is kind of gold standard here for that. Also, I would say that open loop simulations have difficulties and require additional work to simulate and assess the robustness of the system under test against input signal changes. If you think about A/B function, so different sensor installation parameters, vehicle signals like velocity. I mean, you get the ego velocity from the vehicle bus, but that's not perfect signal. It has noise as well. Steering wheel angle, very important as well, but also noisy signal. And sometimes it's not even a symmetric noise, so you need to know basically how to model it. Um, basically everything can impact how the system behaves and how the system will be tuned at the end. So if you need to have a closed loop simulation to be able to tune different calibration parameters for the final vehicle function, which customer will perceive at the end, basically.